Welcome to the fourth of the series. I'm talking to you about network architecture, and I've done the benefit to you of not showing you things like the IMS logical picture, which is a very complex diagram. I've not given you any of the interesting stuff with TCP/IP while I've been doing the videos. If you want to look at those things, I've got them up on my blog. What I really want to talk to you right now about is the wireless side. Because just like what was going on when the computers started whistling into the phone network to get us to the internet, so we went from the PSTN to the internet as being the primary goal of access, now we've got the situation where the same thing is happening to layer 2, and for the wireless side of layer 2. And this gets into issues of whether you're going to use LTE, WiMAX, or what other strategies make sense to you. Now, a lot of the decision as to what makes sense to you is whether or not you are providing access already or not. If you were a 3G company, it's highly likely that LTE is, as they say, the long-term evolution strategy for you. And with things like HSPA from Qualcomm and services from Ericsson, you're seeing people kind of migrate towards those functions. If you're a greenfield or if you're a company that's working in a new space, the WiMAX technology might be the right choice for you. And the funny thing is that while there's a religious war going on, in truth there's much more similarity than there is difference between the two technologies, because they both basically borrow heavily from Wi-Fi and the use of OFDM, orthogonal frequency division multiplexing, and MIMO, which is multiple input, multiple output antennas. So in truth, we're very close to the technologies, and the real discussion is who's got the spectrum to provide the services. There's one other aspect which is kind of important here, which is regardless of which technology we're using, when you move to OFDM, you're starting to move into more antenna needs. So you need more stations out there with antennas. And there's ways to do that on the consumer side, where the consumer has more antenna or stronger antenna. And there's ways to do it on the network side, where the network deploys more. And that kind of brings in issues such as femtocells. It also brings in things like dual mode, where you could actually use Wi-Fi to backhaul things. So the real question you've got to ask yourself is, what are you trying to accomplish and what are your goals in this? But the thing that you should think about is the fact that the network is migrating, particularly for the use of getting to 4G type speeds on the internet. Now, what's 4G? My definition of 4G is that it's an all IP backbone. So basically when the layer 2 all comes up to match up to the applications from an internet backbone, we've achieved 4G. ITU's current definition, or the definition that they're heading towards, is that basically it's 100 megabit mobile and a terabit landline or through fiber. So we've got a lot of definitions out there, and Sprint's claiming that it's 4G already from WiMAX. From what they're doing with the backbone, that's very logical that they say that. But the reality is that 4G's definition is a lot like 3G's definition, which is a lot like 2G definition. And my pal Bruff Turner has done a very good job teaching us tutorials about that, which you can find on the 4GWE website. But the primary thing that we got to remember is that the application side of the equation is really what's driving us now. And I'm going to talk to you more about that on the next segment. Thanks.